Alright, so this is going to be a Solidworks tutorial on how to do a Solidworks flow simulation. This will be internal only, so I'll make a separate video eventually for external flow. But for this one, I'll be doing internal flow. And this will be a part that I made really fast. This is just a Sidewinder turbo manifold, so nothing crazy here. I just kind of made this really fast in a few minutes, so just to be a demonstration, nothing here is made specifically well. But it's just a simple thing with 4 different inlets and an outlet that'll kind of show you how to do stuff for. So very first thing you're going to do is go to your SolidWorks add-ins tab, and if you don't already have it enabled, you'll have to click this for flow simulation. Maybe you already have it enabled though, so if you do, it's going to be on your list here. Very first thing you'll want to do here is go to Tools and do Create Lids. And then once you have this, you'll select any face that has an opening. So for me, my outlet going into where the turbo would go is right there, as well as our 4 inlet pipes for our header here. So we'll have all those lids created. We'll say OK. And once it creates these lids, these will be separate features, so you can differentiate them from the actual model. So you can see here, we have all these lids, and if I want to, I can hide them or suppress them wherever I want to, and there you go, you see they're gone now. So we can show the ones we want to show, which is nice, but for now we'll have them visible. Now for the actual thing here, for the actual rendering, we'll do wizard on the top left, and then we'll go to next. I want to do SI units in my case, internal flow, and we'll also enable gravity here, making sure it's in our Z direction. Nothing else I really care about here too much as far as rotation or free surface. Now this is going to be, you choose your actual fluid, so in my case I want to do air. If you want to do maybe something like a liquid, like water or something, you can, or they even have real gases, but I'll be going with air for this one. We don't know the wall roughness, so I'm not going to add anything for that. And then here we have ambient pressure. We have 20 degrees Celsius, which is 293.2 Kelvin. This will be for your velocity if your part is moving through the air, since this exhaust manifold is going to be all internal with no external parameters besides an engine. We're not going to have any sort of velocity parameters here. And so we'll hit OK. And now we have our control volume box. So this is going to be where your rendering actually takes place. Anything outside of this will not be simulated, so you can adjust the actual size of this. If you go to your computational domain, you can change the size of it, but here we don't really care because it already automatically did a good job. But maybe I wanted to do only a certain part, I could drag it and make it smaller in certain areas too. So make sure it encompasses the entire part you're working with in your little preview there. And then after that, what we're going to do now is we're going to go and set up some goals. So we'll go to global goals, and here's where you'll set up what you actually want to find. So this is what you can actually calculate. If you don't specify it here, you can go back and do it later, but you'll have to re-simulate the simulation again. So kind of make sure you have a good idea of what you want. I want to see the volume flow, mass flow rate, and also the mass of the fluid going through. I'll also go with the static pressure at a maximum, and that should be good. So we'll set OK to that. We have our goals here. They show up as GG. Now we're going to go and we're going to change our sources here. So we have a volume source, surface source. I'm going to say volume, and I'll choose the entire part here. You'll see the lids are no longer a part of the same thing because they actually have it differentiated. And we'll go here and we can set up different things like our generation of heat. We have our volumetric heat generation rate and also temperature. So I'm just going to set the temperature here to 200 degrees Celsius. Alright, so now we're going to choose conditions here. So for conditions, I'm actually going to hide the entire part here. I just want to see the actual lids, so this way we know where the air is coming in and going out of. So the part is now hidden, but we have our lids. We're going to go into conditions here. We're going to set up some of our boundary conditions. So for boundary, we're going to set up the intake here, being where our exhaust is going to come in from the motor. And this is the face of the lid that's facing inside of the part. And we can choose our type here. So I want it to be an inlet. If I know what volume flow or mass flux or mass flow or velocity it is, I would change that. I don't have a specific number for it, so I'm simply going to choose mass flow. I'm just going to choose 1 for kilogram per second. You can also change the type of flow if you want to have it be a swirl, or if you want to have it be a 3D vector, you can choose the exact director. I'm just going to have the vector pointing in the Z direction, so it's fine. I'll also say fully developed flow, that way we're not worrying about the particles not coming out as how it should be, so we're going to have that be fully developed. You also have some things here like your average velocity, your static pressure, whatnot. You can choose those options as well. I set my reference axis to Z here, and OK. Now we have arrows showing where the air is coming in. Now we're going to set up another boundary condition here. And this time I'm setting this one up on the outlet here, which is our T4 flange. And this is where you can choose your pressure now. So I'm going to have my pressure just be a static pressure here. And I'm going to keep these options default from now, since I don't really know the exact numbers we're working with. This is again just a random part I made really fast. So now we can see we have here our pressure opening. Now what we're going to do is we're going to go and we're going to hit run. We'll say new calculation using all the cores in the computer, CPU. Now it's going to go through here and it's going to analyze the model and it's going to start simulating it. So depending on your computer and also how large your cells are, you can see here we have 19,399. That's not too many. Pretty simple part, so should be pretty quick. Otherwise, we will have a long time for calculation. I've made an entire computer before, and it took me about, I think, 5 or 10 minutes with an i9 CPU to render it, so it can take a long time, but this one should be pretty quick. Alright, so now that our solver is done, what we're going to do is we're going to go over here and we're going to re-enable our model. So we're going to hit show. Then we're going to make it transparent all the way. So we're going to do wireframe, which will show us the general shape of the part as well as the internals of it. Also, we can go over here. I'm going to hide the computational domain so we can see the part better. And now we're going to see the results. So we're going to do the drop-down menu here for the results. And so you can choose what type of results you want to view. So I'm going to view the flow trajectories first here by right-clicking and hitting Insert. Then after inserting, we're going to choose where our starting points are. So I want it to be on the lid here, so I'm going to choose the lid. I'm going to choose all 4 for the inlet. And then you can choose the amount of points you have. I'll preview it here. So if we increase the amount of points, right now we have 5 points per header tube. I'm going to choose this to 150. And now we have a lot more, so now you can get a better idea of how it's going to look. What we're going to do next here is we're going to change this from arrows to something a little bit different. If we go over here and we change this to the dynamic trajectories, this will actually have something that changes while you're running it. So I'm going to have it go from arrows. You can do spheres as well. I'll do arrows for now though, and we'll do the velocity. So you can see how the velocity looks here. We can change it to vorticity. We can take a look at acoustic power even, if you have that set up in your settings. Get your temperature, temperature of the fluid. We have our density of the fluid. So there's a lot of different options you can choose and mess around with, but I'm just going to do density of fluid for now. We're going to hit OK. Alright, so now we're going to right click on that flow trajectory, hit play. Now we can see how the flow trajectory works. And so, since this one is the dynamic one, we actually see the flow trajectory arrows changing speed as they normally would. So you can see here at the inlet, past our wastegate here in our actual exhaust flange, we have our velocity increasing, and then coming out of our motor it's going its slowest. So this is how we would expect it to work realistically. we have our 4 pipes converging here, so we're going to increase that velocity dramatically. So that makes sense. We also have a pressure increase from the turbine sucking in the air as it's spinning past the hot side, so that also would relatively help. Obviously, though, if we knew the exact numbers of the pressure, that would be something a little bit different, but that's what we've got there. We can also go back in there and edit it. If we edit the flow trajectories, we can change this one over instead to the pipes. And this one will do if we hit OK on this one. Alright, so now if we have the pipe one, we hit play, you'll see them actually coming out and moving through it. So you can get an idea of where the air is going to go first. And you can see, since these are not equal length runners here, the closest ones are going to go a lot quicker as we'd expect them to. So this is where you can kind of plan out if it's beneficial for you to add equal length runners in this case. But yeah, this is kind of how it is. Now we can also stop this and hide it. I'm going to go into here and I'm going to make a ISO surface. And now if we stop this one, we'll edit definition. We'll go over and change this one to being spheres. Hit OK. And now when we play this animation, it shows it flowing live here, so we can actually see how it looks flowing through here. And the faster the particles are moving, you can see them moving relative to each other. So that's pretty cool. Now if we stop this one, and I will hide it, what we'll do now is we'll do a ISO surface. So in this case, I'll do preview again. Now this one, if we change the value, you can actually see where it looks different depending on where you are within the model here. So in different areas you can see where, based off our graph here, for temperature in this case, we can see where the highest temperatures are occurring and where the lowest temperatures are occurring. We can also go and make a cut plot, and this will basically allow us to choose an axis that we want it to be on. So in this case, we have our front plane, and we can actually move it along and see where it is depending on inside the actual part where this is. And we can change that to being on another plane like this, really however you want it to be. You can see it. Now to increase the resolution of this, you can increase the number here, and it increases the resolution of the actual part there, as you can see. You can also do 3D profile if you want to. And this will offset based off of the magnitude how you want it to look. And if we right click and hit play, we'll see it actually moving vertically, since that's the actual plane I chose. And we can kind of see here temperature as it moves out through the whole part. Now if we want to see the actual part within this, what we can do is go back over to our model here. We'll right click on a feature and hit show. We'll go back up to the top here and select the last option, which has the wireframe view. And now we can see within the actual model what it looks like here. Now you can also do multiple at once, so if we now enable our flow trajectories and hit play, we can see this moving along with the temperature here of our cut plot. I'll stop this guy and hide it, as well as our cut plot. Now you can also do things like surface plots. And if we do our pressure here, we'll use all faces. So you can see what it looks like inside of it now. We have our pressure. And for this one, there's nothing to play since it's not an animation. It just basically shows your pressure throughout the whole system here. We can go ahead and edit this and make it the temperature if we want to. And so we can see the temperature now. We can also go and change within this, similarly to the cut plot. We can do ISO lines and vectors if we want to, like that, so you can get general ideas of airflow direction along the surface. This is not internally, this is the surface. Now we'll hide this guy. Now you can do other stuff as well as animations, but this will all be all I'm showing you for this video to give you a general idea of how this looks and how it works. Now you can also change other things, such as if you want to add a probe to something, you can see airflow at certain points, and you can also see if your geometry is not working, you can do check geometry to help things get figured out. So hopefully you enjoyed this video, hopefully it's helpful for you. And I'll be making a video for external flow as well at some point, and possibly even more advanced flow like inside of an electronic system. So hopefully you enjoyed the video. I won't be probably making too many Solidworks videos in general though, so don't expect regular uploads for that, but hopefully this helped you out.